Okay, so we can wait 2, 3 more minutes and then I can start. If somebody else can join on as well. Okay, so let's start. So I will just brief about week 6 today. So it's the week 6 summary. So so today mainly I will discuss some convolution properties and the direct delta function convolution, and we will solve some problems also on convolution. And if time is left, then we can go to uh, invertibility, instability, all those of LTI system. Okay, so basically in week 6 we will be dealing with operations operations on LTI system. So everybody is clear with LTI system, like what is LTI system? So you can put thumbs up if you are clear with the concept of LTI system, or else like I can brief about the LTI system. So anybody has any doubt about the LTI system? Okay. So I'm guessing that everybody knows about the LTI system. So in the last week's live sessions, the about that convolution. So now you're familiar with the concept of convolution. So have you, Rohit? So no for not clear with the LTI system. Okay. So LTI. So LTI. So I will just brief about LTI. Okay. So another question, then I can take both the questions together. So the concept of convolution, is that clear? Like what are the steps, how the convolution is done step by step? If you have watched lectures and the video lectures and the live sessions, so do you want me to repeat that as well, or you are clear with the convolution part, like step by step how the convolution problem is being solved? So clear with that part? Thumbs up, or not clear, then thumbs down. Okay. Okay, okay, not clear. Okay. So, okay, then today I will just very step by step, uh means slowly I will take the convolution part as well. Okay, so firstly, before convolution, like what is a LTI system? Okay. So, okay, the students, those who have joined now, so I am going to just review the convolution part. So, I'm going to do it step by step so that the convolution, the convolution operation on signal is clear to you. Okay. So, firstly, so for convolution, so convolution is only and only applied on LTI system. Okay. So if the system is not LTI, then the convolution cannot happen. Okay. So what is LTI system? So in LTI, your L stands for linear and your TI stands for time invariant. Okay. So so what is linear when the system is linear? Okay, so now you are clear with with week 5 you must have noticed that you have been uh, shifted from signals to systems. Till week 4, we were discussing about signals, all operations about signals, all transformation about signals. Then you have now being advanced to systems. Okay, so what type of systems? What are the different types of systems? How what all operations are done on a system, and like causal, non-causal, variant, non-invariant, all those. Okay. Now, what is happening in convolution? So, convolution is an operation that is applied on signals, but the signals should be for the LTI system. Okay. So now the overall gist is here we are combining signal and system. So signal means operation is being performed on signals, and what operation? Convolution. But the signals should be of what system? It should be an LTI system. Okay, so that is linear and time invariant. Now coming to what is linear and what is time invariant. I guess little bit you must be aware like what is linear. So linear holds again two properties. So that is homogeneity and additivity. Homogeneity and additivity. So these two, homogeneity is like multiplicative. So I can write it as superposition. Okay, so before that, can anybody let me know like what is a linear system? If you have gone through the previous lectures, like what is a linear system? Anybody?
In which if we give anything like a and x1 of t, then that a will come out.
A will come over as means. Can you give an example?
It would be y of t is equals to x of t. It would be linear, and non-linear would be y of t is equals to x of t plus into x of t plus t.
Or we
Uh,
can set yt is equals to 3 xt t minus time shifted version of t 3 t minus 2.
okay, so yeah, so you both are giving an example for a linear system, right?
Yes, ma'am.
Okay, okay. Yeah. So let me explain that in detail. So linearity holds again two properties. One is superposition and the other is homogeneity. Okay. So now superposition is, you can say, additivity, and homogeneity you can explain it in terms of multiplicativity. Okay. So that means, so now superposition, let's understand what is superposition. So superposition, let's see what happens. So you have one signal xt. Okay. So now you are passing to the one system, so x1t. Okay. You're passing to one system, and then the output for this is y1 of t. Again you take another input. Okay, now the system is same. Okay, system is same, so the same system. Okay, maybe the system is some reversal operation or something is happening in the system, and you get the output as y2t. Now what you are doing, you are giving input as x1t plus x2t, again giving to the same system, and you are getting the output as y1t plus y2t. Okay, so if this is being followed, then the system is additive in nature, means it's superposed. So one of the criteria for linear is fulfilled, that is superposition. Okay. So you can get a question. So some system is there, and these have some value, suppose ut, and then this is rt, and you are getting some so the system means some operation is being done, and you get the output according to that operation, and you get this y1t. So you have x1t and x2t, and the question has been asked, if these two have been cascaded, then what will be the output? So output will be very simple. It will be the addition of the outputs of these two. Okay, so if this is not followed, means x1t plus x2t does not give the output as y1t plus y2t or something else other than this, then it is not superposed. Okay, so superposition is clear, or any doubts? Okay. Yes. Good. So yeah, Jay Patel is told about satisfy superposition. So yes, so this is one of the criteria for linearity. Now the other criteria is homogeneity. Okay. So again, we will take one signal. This is my input. We give it to this in a system, and then we take the output as yt. So this is my output. Now if my signal is being scaled, so a x of t, I'm giving to this to a system, and now my output is a y of t. So now the input is changed, that is being scaled. So similarly my output is being also scaled, okay, by a. So this is homogeneity, basically a multiplicative property. So if homogeneity and superposition is being satisfied, we say that the system is a linear system. Okay. So now LTI also holds this TI. Okay. So linear is done. Linear should hold two properties, superposition and homogeneity. And superposition is nothing but additive property. Homogeneity is nothing but multiplicative property. Now coming to time invariant. Okay. Okay. So now let me change the color. So time invariant. Okay, so this in week 5 this has been discussed as one of the type of system. So what do you understand by time invariant system?
So if we change time in
Hmm.
input signal, so that same shifted or scaled version should be in output also.
Yes, correct.
Or ma'am, we can say the delayed and advanced input gives the delayed and advanced output.
Yes. So you can say that, but let me explain it like in diagram, like what is basically time invariant when you can say. So there should be a shift, but how? Okay. So, so the input is suppose x of t. Again, I'm taking the same example, and then I'm giving it to the system, and then I'm taking this as an output. Now, I will take two cases. Okay. So whenever you get a question that you have to check whether the system is time invariant or variant, you have to like if you can follow this step, means like the method that I'm telling now, you will always get the answer because this is like step by step procedure to how to check whether system is time invariant or variant. So we will take two cases. In the first case, we will delay the input. We will delay the input by some delay or advance. We will just have a shift. Input is, so I'm taking a case of delay, but you can always take a case of advance also, is delayed. Okay. So now my xt is being changed to x of t minus t naught. Okay. So now when uh, so now my input is given to the system, and what output I am getting it? I'm getting the output as y of, so I'm passing to such a system that the delay in this input gives the output as y of t minus t naught. So the delay in input is causing the delay in output. So this is case one. Okay. So from x t minus to t naught, you are getting y t minus t naught. Now we will take another case. So in this, what we are going to do here, we are delaying the we are creating a delay in the system. Okay. So I wanted to give you an example. So just a minute, I'm searching for that example. What's that? I'm not able to find out. Okay. So here what I'm doing is delay in the system means, so I'm taking the input as xt only. Okay. So this is my input. Now it's going to the system. Okay. So the system, it is passed through that system. And so after this, after it's passed to the system, it becomes yt. And now we are adding this delay. So you can say a delay by t naught. And now I'm getting this is output as yt minus t naught. Okay. So the thing is, this and this should be equal. Okay. So 1 and 2 should be equal. Then only we can say that it's time invariant. Okay. So till here, any doubt? Like, what is time invariant?
Clear, ma'am.
Okay. Okay. So like, I wanted to give an example. I'm not able to find, just a minute. So then it becomes more clear. Hmm, just- hmm. Oh, just 1 minute. Okay. So recording is started. Hmm. Okay. So let me give one example for to test whether time. So the system is like, so if suppose yt is the output, so for x of 2t means this implies what? So xt is one input. It is passed to the system such that the output is x of 2t, means time scaled. Okay. So let's check whether this is time variant or invariant. So from case 1, what we can do is create a delay in the input. So delay in input. So now my xt becomes x of t minus t naught. Then I'm passing it to the system. So what is so x of t minus t naught. Now it becomes, so when it's passed to through the system, so my system, what it does, it scales the time. Okay, it scales the time. So it becomes what? It becomes, look very carefully because it's very critical. So your output now becomes, so yt is what? X of 2t. But now my t is being delayed. So x of t minus t naught will give you y of t minus t naught. And what is yt? X of 2t minus t naught. Okay, so this is one. And now in case 2, what we will do? We will create a delay in the system. In the system, as in, we will take as input as it is xt. So now, uh, it will give yt. So yt is what? Yt is x of 2t. So now this x of 2t. So now we are creating a delay in the system. So that means wherever there is a t, so t is changed to t naught. So that means Now my output will be x of 2t minus t naught. Okay, so it becomes x of 2t minus 2t naught. So look very carefully. This is 1 and this is 2. So both are not equal. Okay, that means this is time variant system. Time variant system. Okay, so now you understood that what is time invariant and what is linear. Okay, so coming back, so convolution is only possible when the system is LTI, that is linear and time invariant. So there can be a trick question where you can, where it's asked like perform convolution of on this thing, but you should check whether the system is, firstly check whether the system is LTI or not. है ना? If the system is LTI, then only convolution is possible on the signals. Okay, so getting very late, so let's quickly start with the convolution. Okay, so what is convolution? So with this convolution operation, we can say now, suppose again there is a signal, this is an input, you're passing this to a system and you're getting this as output. So how we know this? Okay, so this is like in figure, but how can we write this mathematically? So we can write this mathematically as yt is equals to xt convolution with h of t. And what is h of t? It's the impulse function of system. Impulse function of system. Now, so ht. So let me ask you, what do you understand by this impulse function of the system? Anybody?
It's a factor of direct delta.
Can you repeat?
It's a scaled version of direct delta, or it's like when we uh, integrate with direct delta, then we get this impulse response.
Yeah, yes. We get the impulse response. Okay, yes. So basically, the thing is, whenever your xt, whenever your input is a delta function and you pass it through the system, okay, pass it through the system, then the output is your h of t, which is the impulse response. Impulse response. So when it's the output, when the input is a delta function, we call this as impulse function, sorry, it will be response, impulse response of the system, and we denote it like this. So it's basically the transfer function of the system. Okay, it defines the system. So input is input. Okay, input can be anything, like whichever signal you can pass. You can pass a sinusoidal, you can pass a unit step, you can pass a ramp, you can pass a rectangular function, anything. Okay, but the system is something which is doing to that input signal. Okay, it's taking that input signal and it's processing to transform that input signal. Okay, so that transformation is being defined by this h of t. And then once it's transformed, we get the output and it's being displayed in your display unit. Okay, now you understood this convolution operation. But how? Okay, so now you got, okay, if there's some function xt, you know ht, you are doing convolution operation and you're getting yt. But how to do this convolution operation? So, uh, so another way of writing it is y of t is equals to minus infinity to infinity x of tau h of t minus tau. So basically convolution is this. Okay, so it involves some steps. So this you can look very carefully, like what are these steps? So firstly, whenever there is a question, what you will get? You are getting your input signal, that is your x of t. You will get your transfer function, impulse response, and that is uh, h of t. Okay, so this will be something in time domain, this will be something in time domain. So your first step is um, convert, because we are dealing, okay, sorry, I forgot this d tau. The integration is with respect to d tau. So once you see that the integration is with respect to d tau, then for immediately convert your, so this is like very step by step. Okay, you can just always skip some steps and do the direct operation, but I'm going with all the steps. Okay, so convert t to tau. Okay, so you're converting your t to tau. So then what will happen? You will be you are now ready with your x tau and h of tau. Okay, now what will be your step 2? Your step 2 will be, you will do the, so x tau. Okay, so now we will not do anything to this x tau. X tau is being masked, means it's fixed. Okay, so this is fixed. So in convolution operation, one of the you can say one of the function is being fixed and the other is being moved. So that is moving. So that I will show, like how is it moving. But so we will fix this x tau. So this is fixed and this is moving. Okay, so your x tau is fixed, your h tau is moving. So now from step 2, whatever things will be there, it will be to h of tau. So we will do a time reversal first. Okay, so now my h, okay, so let me write this with different color. H of tau is changed to h of minus tau. Okay, now step 3 is your time shift. Time shift. So time shift is we are advancing that signal. So now h of minus tau becomes h of minus tau plus t, which we can also write at h of t minus tau. Okay, so now we are having this term h of t minus tau. We have got this. And we have also transformed xt to x tau, just changing the variable, nothing else. So now we are good to go with the integration part. So step 4 is, firstly we have to multiply these two signals x tau and h of t minus tau. So multiply. Okay, so this involves what? X of tau into h of t minus tau. And the final step will be integrate. Okay, that means minus infinity to infinity and this part. Okay, so this is how we get the convolution means we will get the output yt if we have xt and ht by following these steps. So far, any doubt?
No, ma'am.
Okay. Jay, you have any doubt? Okay, okay. Okay. So I have to do the properties of convolution and some direct delta function also. So do you want me to start with that, or do you want me to solve a short example in convolution first and then go with the properties?
Ma'am,
Ma'am,
example.
example.
Okay, okay, fine. Okay, so if you have your pen and paper, no, so just take out and just try to solve with me. It will be good exercise for you as well, right? So, okay, so let me start. So I'm taking an example again, x of t. So in the any of the sessions, like is any example of convolution being solved? Like um, somebody took that?
Ma'am, give me a minute. I'll check it and let you know.
Means so that I'm not solving the same question again. You can get a different flavor of the question. So this Ananya, check and tell me, like, if it's solved, then what was the question? Like a brief about that.
First one was ut, convolution e of e to the power minus t ut. And
Okay.
yes, only
So
this one.
no question on rectangular functions, no?
Uh, Ma'am told us the tricks and solved two questions on rectangular functions.
Okay, to get the trapezoid and triangle, those things.
Yes, ma'am.
Okay, okay. So I will just take one example and like step by okay, Sonali, do we need to exact these steps for the convolution? We do shifting first or time reversal next. Okay, so either way. Okay, you can also go with the other method, like we used to do in the transformation of signals. We do scaling first and then shifting, or shifting first and scaling. Just take care, like whether it's following the same thing or not. Means some care has to be taken once the reversal is done after shifting. Okay, like scaling is done after shifting, then you have to take care of that term, compensate that term now. So that thing you just need to be careful, otherwise you can do either way. Okay, so now I'm taking an example. I'm taking two rectangular functions. So so I will come to that shortcut also, but let me do it with step by step, and then we can then I will tell you the short trick for evaluating these things.
Ma'am, these things is done taking two rectangular of same width and of another width. First,
Mhm,
for same width it
mhm.
gives triangular, and another for the different widths it gives trapezium. And the shortcuts
Trapezoid,
is
yeah.
also can is also done in the previous lectures. So can you take a
Okay, so
different one?
so different question, you mean?
Yeah, yeah, different questions, or we can or you can say uh, yes, ma'am, different question. Because previously, I think a day before yesterday, it has done,
Mhm.
and the lectures was 3 hours, 8 to 11. So all the topics is. covered, and mostly this question taking two rectangular functions
Uh-huh.
is done.
Okay,
So can you
okay,
take a different one, or
okay,
the advanced version of that?
okay, okay. So let me do one thing. So, okay. So then let me go to the properties. So after giving like a brief about properties, then we can go to solving the question. So that will be advanced questions. Means so it will be a convolution question, but it will involve something else also. So that I can firstly discuss like what are the properties, and then I can go to the questions. Okay. Okay. So So my first so let me write properties of convolution. So first property is your commutative. So what do you mean by commutative? That means if some input is there, x1t, and that is being convolved with, so there are two signals, okay? So x1t and x of t. Now, if both are convolved, we get the output as what? Y of t. Okay, but just now that I have told that one is fixed, okay, one is fixed and the other is moving. So this can be your transfer function, means h of t. Now, if I change the order, that means x of t, x2 of t convolved with x1 of t, this will also give the input as y of t. That means your sorry, output. So that means your output remains the same. So now here, what is that? Now my x2t is fixed and my x1t is moving. So if you must have solved the question, so suppose there are two rectangular functions. So there are two rectangular functions. So suppose this is the one that is fixed and this is the one that is moving. So it's moving like this, it's moving like this, it's sliding, okay, in the time axis. So, so the orange one is sliding, but the reverse is also true, means your black one can slide and orange remains fixed. Suppose the orange one is this. Okay. So either way, the output will be y of t. So this is commutative. Okay. So means if suppose this is some function u of t and this is some function u of t minus 2 and you are given an output, and then it's the question is telling that now it's being reversed, means now this u of t minus 2 is now my input and u of t is your transfer function, that is h of t. Then what will be the output? Then you just no need to calculate it, but you can say the output is the same as a as that of the, like, when u of t was an input. Okay, so this is the commutative property which convolution holds. So, so if the question is like, is commutative true for convolution? Yes, it is true for convolution. Okay, now number two. So number two is associative. So associative is, so now we have three functions. Suppose x1t convolved with x2 of t. Okay, and this whole is being convolved with x3 of t. So this is my y of t. So then what is true also? If x1 of t is convolved with h2 x2 x2 of t convolution x3 of t. Okay, and that also gives the output as yt. Means if you do first these two convolution, get this as an input and convolve with x3, you will get yt. But you can also x1, if x1 is your input, convolve with this whole as your transfer function or impulse response, then again you will get this yt. So let me put this in a figure. So this is my input, and now, so suppose this is h1 of t, this is your impulse response of the function system, and now it is passing through h2 of t. Okay, and you get this output as y of t. Okay, so this is x x xt convolved with h1 of t convolved with h2 of t will give yt. What we can do in another way is, your xt is convolved with, so this, are you getting? So let me explain this. So here what you are doing, yeah, so here what you are doing, you are doing, so how to proceed with this? So this is x of t convolved with h1 of t. Okay, so now this becomes your input, and this is going to h2 of t, and you're getting y of t. That means, so this you are doing first, then you are, so xt convolved with h1 of t, and this whole, once you evaluate this, you are again convoluting it with h2 of t, and you are getting this as y of t. Okay, what the other thing says is, x of t is passed to a system which is convolution itself, a convolution of two functions, h1 of t and h2 of t, and you get this as an output. So that means x of t. So how do you write this? You convolve is with h1 of t convolution h2 of t, and you get this as y of t. Okay, so both the operations, both the transformation will give y of t. So this is associative property. Okay, clear everybody?
Yes, ma'am.
Okay. Okay, so now the third property is distributive. So this is very important. So look this very carefully. So x, so suppose x1 is x1t is your one of the function, is convolved with addition of two functions, and this gives me an output yt. Okay, so this is giving me an output. Okay, so now what, how we can write this again is, x1 of t convolved with x2 of t. Okay, and x1 of t convolved with x3 of t, and this will again give me an output as yt. Okay, so this property now, where it is used, I will just solve one example, then you can see the beauty. Means you have to play mindfully, like whether you have to use, you should solve the question by this method or this method, because both gives the result, but one saves time and one is lengthy. So from, if you know the property, you can always go with the one which is being solved in a shorter time. Okay, so that's why these properties are important, and particularly this distributive property. I will show with an example, but let me complete the properties first. So fourth is your direct delta function property. Okay, delta function property. So what does this say? Okay, sorry. So firstly, let me draw this one. So what one? Suppose this is one and this is two. So for one, how you will draw this? So your x1t is an input, and you are convolving it with what? X2 of t plus x3 of t, and you're getting this as input as yt. From 2, how you can draw? So x1t is being convolved in x2t. Okay, so x1t, x2t, and plus x1t is also convolved with x3 of t. So that means x3 of t, and both are being added. So I will add one adder over here, and then is my output. Okay, so this in pictorial form it looks like this, and this one is this, but both are equivalent. Okay, so now coming to the fourth property, that is direct delta function property. So what this does, this tell? This tells that if suppose my input xt is convolved with a impulse response which is a delta function, a shifted delta function. Okay, delta t minus t naught, then what will be your output? It will be simply the shifted version of the input signal. Very simple. Okay, xt convolved with delta t minus t naught will give xt. That means, now you tell me, if there is no time shift and your xt is simply convolved with the delta function, then what should be your output?
X of t.
Very good. X of t. Okay, so this is your delta function property. Just tell me quickly, if xt is my ramp signal r of t, and uh, the impulse response is delta t minus 2, what will be the output without any convolution? Xt convolved with delta t minus t naught will give?
RT minus 2.
Correct. R t minus 2. Okay.
Okay,
Yes.
ma'am. Convolving is different because we shift it to left to right. But if we do
Mhm.
multiplication, then that zero or that t naught comes in, right?
Multiplication where?
When we multiply it, like r of
Ha
t
ha
with
ha ha.
delta t
Yes.
minus 2.
Right, right, right. So that multiplication thing which we did the in earlier classes, right? So that property, and yeah. So you have to check very carefully. So when once this is convolution, this will be the thing. And for multiplication, as you have done in the previous class, like that direct delta function property, additive and multiplicative. Okay. So now you are good with the properties. So okay, so there I'm going So can we just extend to 10 minutes more so I can do an example and two more properties? So fine with everybody? Okay. So fourth, okay. So fifth property. So this will be very handy for solving the questions. That is time delay in convolution. Okay. So what does this say? So if your x1 is this input signal and it's being delayed, suppose by t1, and now it's convolved with x2 of t minus t naught. So the output, what will be the output? And you know that x1t convolved with x2 of t will give the output as y of t. So what will the delay will do to this? So delay will delay is y of t minus t1 plus t2. Okay. So in a way, suppose so you know that okay, tell me, ut convolved with u of t will give what?
U of t back again.
No. So step signal convolved with step signal will give what?
Ramp.
Right, ramp. So that is why now you get, if you have a rectangular pulses of equal width, you get a triangle because it's just the combination of two ramps. Okay, up ramp and down ramp. So if so, this is what it's the combination of two step signals. So if you have a continuous step signal only and you have is convolved with another step signal, you always get a ramp. So that is r of t. So now you know this. Okay. So now if this is your x1 of t and this is your x2 of t, and I'm delaying this with uh, x1 t minus 1 and x2 is delayed with x2 t minus 2. So without solving, can you tell me what will be the output of x1 t minus 1 convolved with x2 of t minus 2? What will be the output?
RT minus 3.
Very good. R t minus 3. So this, how does it happen? R of t minus t1 plus t2. T1 is 1, T2 is 2. So R t minus 3. Okay. So if you get a question like this, you without solving, you can get the answer. Okay. So this is the time delay property. Okay. So now, so now we will solve just one question.
Ma'am, I had a doubt.
Yes.
In exam, what kind of combinations of signals will be there for convolution? Like we had done square, then
Hmm.
triangular, trapezoid, exponential. Like what will be the combination?
So that directly I can't tell, but the signals
Like
will
it
be
will
the,
be easy, then we can know the properties. Like we can memorize them. It will be fast then than to
yeah.
solve there.
So, so likewise, like I have taken the example of UT, right? So, so not very. Means you will be familiar. So, if you recall the like functions and properties from previous class, you will be able to get that in the question. Okay, so it will nothing be out like whichever means some trapezoid convolved with some triangle or something, and you will obviously you are able to, you have to solve that mathematically and get the answer. Okay, so if you get this short question, it will obviously will be the one that you are familiar with. Okay, you the convolution, the output of the convolution, you must and must have done it earlier in earlier classes. Okay, So likewise, the question that I have given now. Okay. So, okay. So now there is a question. So you have an impulse response ht is equals to delta t minus 0.5. Okay. So now, so now if there is an input, that is x of t, and this input, if I say, uh, it's been cascaded with two such systems. Got it? So xt is an input to the cascaded to ht, then what will be my output? Okay. So let me simplify this. So this is the language of the question, but let me simplify this and tell you, like, xt is being convolved with two such outputs. So h of t and again h of t, and then you have this y of t. Then what is this y of t? So can you just quickly calculate and tell me in terms of xt only, because xt is xt.
So, ma'am, it is x of t convolved with this h of t once, right? Or h
Hmm.
of t twice.
Yeah, so that you have to just think and tell what will be that. So are you,
If we do it once, then we will
hmm,
get x of t minus 0.5.
when we do this part, right?
Yes.
Yes. So then what we will do?
Then we will get x of t minus 0.5.
Okay. So we will solve this step by step. So firstly, we will perform x of t convolved with h of t, this part. So this will give me, as you told, it will give me the output as x of t minus 0.5. Now this becomes my input, and it's again convolved with h of t, and we get this the output. Now tell me what will be the final result of it?
X of t minus 1.
Correct. X of t minus 1. And how did we get this? So this is my input, and it's again convolved with delta t minus 0.5, and you know convolution with delta function gives, so x of t minus 0.5, and again we do this minus 0.5. So we get this as x of t minus 1. Okay. So the output is x of t minus 0. So any doubt? Yeah, Sonali, tell me what's the doubt?
Ma'am, why we are not using here the limits minus infinity to infinity as per the
Uh,
definition of the convolution?
so here we are not doing in that manner, no. So yeah, so the limits are always there. So when you do that, so that is the lengthy process. Okay, but through the, so we are doing this through this property, the property that I just told, xt convolved with delta t minus t naught. So this gives xt minus t naught. So we are directly applying this property over here. Okay. So xt convolved with ht. So ht is nothing but the delta function, shifted delta function. So we are getting this directly, xt minus t naught, t minus t naught. T naught is 0.5. Now this becomes my new input. So this is the new input, which is again convolved with h of t, which is delta t minus 0.5. So now this new input convolution with, So this again follows that property. Okay, so we will again using that property. So so this is your input, and we are again using that property. So this is again shifted by minus t naught. So we are getting this final output. So we're using just the property and placing the results.
So, ma'am, could you please solve some questions in which we have the limits?
In the limits. Okay, so I will just paste some of the questions in the G space after this class with some limits. I'll search for some good questions for that. Okay. Yeah.
Okay.
Ma'am,
Yes.
can you tell the derivation of this property which we applied here? I'm not able to understand how we get delta t minus t naught as xt minus t naught.
Okay, this property.
Yes,
The this property now. Okay. Yeah, so I have the proof of this. I will just paste it in the G space. Okay, the PDF for this. So you can go. And if you have any questions, then you can surely contact me. Okay, and I will explain. Okay, so shall we end this class because it's like 30 minutes more. So okay, we will meet now next on I guess Monday, no? Monday is the next live session, right?
Yes, ma'am.
Okay. So Monday, I will take the brief about the other things, no? That time invariant causality memoryless for LTI system only. Okay, so we will be dealing with LTI system apart from convolution, and we'll be solving some problems on that. And one more thing. So I will be taking the MATLAB sessions as well in this term for signal and system. So that will be every week on Tuesday from 6 to 7 p.m. Okay, I will just announce this also in G Space. And so the assignments that you will be getting in future, I will just take the conceptual things and how to code that in MATLAB. So that will be it will be helpful to solve the questions of your assignment. Okay, so so that will be there. So this I will just now only announce to other students also. If you and if you if you can pass this information to other students, that also you can do. Okay, so we will be meeting
Ma'am,
on
when is
Monday,
the class?
on Tuesday from 6 to 7 p.m.
Okay, okay.
Okay.
ma'am, but we have deadline tomorrow of week 6.
Week 6, the not the MATLAB assignment, no?
Yes, ma'am, but I'm talking about the other things which is left in week 6.
Okay, so tomorrow. Okay, so yeah, so I'll be taking the session on Monday. So, if you were stuck in some question, you have some doubt, in practice. So I graded. I can just brief, but I will not. I cannot solve that exact question. But yeah, if you have some confusion or something, surely can paste in G space, and I will try to help you out. Okay, so because the next session will be on Monday, so the deadline is tomorrow, then yeah, so because some of the topics are left for week 6.
Ma'am, is it possible to take a 30-minute more class and explain those?
Actually, so I have to go somewhere, so I have some meeting else here only in college.
Ma'am,
So
tomorrow can be possible?
tomorrow, when you have
Maybe
it,
in the night.
so shall I prepone the session for Monday to tomorrow?
Yes, ma'am. Sunday morning.
Sunday morning. Okay, so yeah, okay, then okay, so then let me just talk to Vishal, and if it's fine, then I can take the session for that, which is on Monday, and I will take the session on tomorrow. Okay, and there I will be just covering the rest of the part of the this week 6.
Okay, thank you, ma'am.
Okay. Okay, so I'm just stopping the recording.
Thank you, ma'am.
Okay, thank you.
Excuse me, ma'am.
Yes.
Ma'am, I am not be able to log into the MATLAB. I
Okay,
done
so
all the steps, but I done all the steps, but for the
Sonali, you have
verification,
to
I
create
didn't
an
get.
account first with your student
yeah, so
email.
did you create that account?
Ma'am, I follow all the steps, but I'm not getting the verification code.